Look at this problem. 1 plus 2 plus 2 square plus so on up to 2 to the n is 2 to the n plus 1 minus 1. How is this true? Pause the video and try it all by yourself. You needn't necessarily use induction here, but I will give you a proof using induction. Okay, so now we are back. Probably you tried proving it without induction. I'm sure some of you succeeded, some of you didn't. Don't worry. If you understand the binary representation of a number, you will get a hint how to proceed with a solution for this problem. Anyways, forget all that. Let's now try to see if we can use induction. So, let me consider 1 plus 2 square 2 to the k equals 2 to the k plus 1 minus 1 as my induction hypothesis, right? Firstly, I should check the basis, the base step, right? So what is that? When k equals 1, this will be, I'll check it for, let's say, 0. P of 0 is when it is simply 1, which is equal to 2 to the 0 plus 1 minus 1, which is equal to 1. So now the induction hypothesis is, I am assuming P of k to be true, which is 1 plus 2 square up to 2 to the k is 2 to the k plus 1 minus 1. We need to prove that for P of k plus 1, this is true. So what do? Simply add one extra term on the left side. That is what you mean by P of k plus 1, which is 1 plus 2 square up to 2 to the k plus 2 to the k plus 1, which is equal to, we know by induction hypothesis that this is 2 to the k plus 1 minus 1. And then I'm adding one more term here. Look at this, one more term, which will make it 2 to the k plus 1. And now I do a small jugglery. I take 2 out here and I basically observe that 2 to the k plus 1 plus 2 to the k plus 1 is 2 times 2 to the k plus 1. I write 2 outside. By outside I mean a into a plus a is 2a, right? So I get this minus 1, which is same as 2 to the k plus 2 minus 1, and that is what I wanted. Observe, right? P of k plus 1 is also true whenever you assume that P of k is true, and hence the given formula holds good. We thus have illustrated that with mathematical induction.